And we're going to take a look at another notion called abstract classes. And what abstract classes do is they allow us to provide for the fact that subclasses are required to have certain methods without us necessarily defining the actual method itself within the class. So let's take a look at this. There are occasions when we want to design a class that is specifically designed to be subclassed and not instantiated. So we have this concept called shape. Okay, and within shape we say that, you know what, all shapes should have an area method. Nothing else needs to be defined other than that. And from shape, we would say, okay, rectangle is a kind of shape, triangle is a kind of shape, and circle is a kind of shape. So the area method for all three subclasses are implemented differently. This is length times width, this is 1/2 base times height, and this circle is pi r squared. And so each area method is different and technically would need to be overridden, but an area for a shape is really not defined. You couldn't clearly define it. You know that every shape must have an area, but you couldn't define it as such because there was nothing to define. So what we do is we actually will create a method called area that is an abstract method. And this is kind of like the how the method is defined. This is what's known as a function stub. The line is abstract int area semicolon. This is within this shape class. So what will happen is it will say that shape has this method called area, which we have not defined what it does. But any of the classes that subclass it must, or that inherit from shape, must provide an area method. And that provides for uniformity, it provides for consistency, because we would like all of our rectangle, triangle, and circle classes to have an area object. And you may do this for perimeter. If you want to choose to, circle would be a circumference, which would be the same. So these are known as abstract methods, and any class with an abstract method must be declared as an abstract class, and we will use the keyword abstract in front of the word class. And so therefore, the subclasses will provide the function methods of abstract methods within abstract classes. So this is what the code actually looks like. We have this class called shape, which is an abstract class, and the function stub abstract int area is the function stub. This must be overridden by anything that inherits or from shape. So here's an example. Class circle extends shape. Since shape is abstract, all of the abstract methods must provide some code. So we have int area. Area returns of type integer, and so therefore this returns of type integer. Had there been parameters in here, then the parameters must appear in here as well. It must be the same number and the same type. The variable declarations do not matter. Here we'd return pi times radius radius, assuming that pi, radius, and radius are already defined. So this code is overriding the abstract method in int area. Again, I do class rectangle extend shape, and this method overrides the function stub in the abstract class shape. So abstract classes can also have a combination of abstract methods and concrete methods. Those methods are executable code. So for example, I may have a variable called string name, and this would be a name for the shape. Here's my function stub or the abstract method, but then I may also provide a method that sets a name of the shape, and it doesn't have to be rectangle, it could be shape number 64. And this is the actual concrete code. So the circle class and the rectangle class from the slide before would now have accessible to it this set name method, which it could use. And it could be overridden if the programmer wanted to, but in this case it is providing at least one of the methods. So abstract classes allow you to have a combination of both abstract methods as well as concrete methods.